Question we are solving now belongs to test series 8. It is of network theory subject. In specific, it belongs to transient response analysis of RLC circuits. As per the question, there is a RLC circuit given as shown in the figure. It contains a 10 volts voltage source, 4 ohm resistor, 1 Henry inductor, and 2 farad capacitor. There is another 2 ohm resistor and 4 ohm resistor across which there is a switch connected as shown, and the switch is closed at t equal to 0. The drop across the 2 farad capacitor is Vc of t. We need to find dVc by dt at t equal to 0 plus. As per the data, the switch is closed at t equal to 0 plus t equal to 0. Now first, let us draw the equivalent circuit for t less than 0. In specific, let us draw the equivalent circuit at t equal to 0 minus. So at this instant, both inductor and capacitor would have reached the steady state, due to which inductor acts as short and capacitor acts as open. So from this we can say that Vc of 0 minus is equal to the drop across the 6 ohm resistor, and it can be written as 6 volts, and IL of 0 minus is equal to 10 divided by 10, that is 1 ampere. We know that Vc of 0 plus is equal to Vc of 0 minus is equal to 6 volts. We also know that IL of 0 plus is equal to IL of 0 minus is equal to 1 ampere. Now let us draw the equivalent circuit at t equal to 0 plus, because we need to find dVc by dt at t equal to 0 plus. As the switch is closed at t equal to 0, this 4 ohm resistor gets shorted. Hence the equivalent circuit can be drawn as shown. Please note that at t equal to 0 plus, the current through the inductor is 1 ampere and voltage across the capacitor is 6 volts. So from this data we can see that this complete 6 volts appears across the 2 ohm resistor, hence the current through the same is 6 by 2 is equal to 3 ampere. So based on this data we can say that IC of 0 plus is equal to 1 minus 3, that is equal to minus 2 ampere, which can be written to be equal to C multiplied by dVc by dt at t equal to 0 plus, and this is equal to minus 2. But we know that the capacitance value is C equal to 2 farad. From this we can say that dVc by dt at t equal to 0 plus is equal to minus 2 divided by 2, that is equal to minus 1 volts per second. From this we can say that the correct option which represents the required value of dVc by dt at t equal to 0 plus is B, as it corresponds to minus 1 volts per second.